Mathematics at Init College, a YouTube channel for high school mathematics education, Mathematics 3C and Mathematics 4 Swedish education system. The definition of the derivative. Hi, this is Babak. In this video I'm going to solve the following problem for you. Use the definition of the derivative to determine the derivative of the following function. F of x is equal to the third root of x plus 1. I recommend you to give the video a pause at this time and try to solve the problem yourself first. If you do everything correctly, the final answer that you will get is f prime of x equals to 1 over 3 times the third root of x plus 1 squared. Okay, now let us solve the problem. I'm supposed to use the definition of the derivative to find f prime of x. So I will write the formula, the definition of the derivative. So it becomes the limit of f of x plus h minus f of x divided by h when h goes to 0. Okay, so now I would write this for this function. Okay, so what is f of x plus h? It means that I need to refer to my function. Wherever I see x, I take it away and I replace it with x plus h. But here I don't need any pair of brackets. I can just simply write x plus h. So this becomes the third root of x plus h plus 1, and then minus the third root of x plus 1 divided by h goes to 0. Yes, so let me just repeat. F of x is this function itself that I have written here. F of x plus h is the same function, the only difference is that the x has been replaced by x plus h. Now I am supposed to calculate this limit. For calculating the limits involving the third roots, you need to know another algebraic identity. So let me write it here. So we know that if I have a minus b multiplied by a squared plus ab plus b squared, it will give you the third power of the first one minus the third power of the second one. So you need to remember this identity. This is a very useful identity. So here, if I have two numbers subtracted, and then I have the first one to the 2, the product of these two numbers with the opposite sign, here it's minus, but here we have plus. And finally, I have the second one squared, and I want to multiply them. I can just simply raise the first one to the 3, second one to the 3, and then subtract them. It's very easy to convince yourself of this identity. I will start, for example, from the left hand side, and I simply start multiplying these two pair of brackets. So the first one becomes a to the 3 plus a squared b plus ab squared. So I took a and I multiplied it here, here, and there. And then I will take minus b and I will do the same thing. So this becomes minus ba squared minus ab squared minus b cubed. And then you can immediately see that a squared b and minus a squared b are cancelled. This one will cancel that one, and what is left for me are just these two terms, which is exactly equal to a to the 3 minus b to the 3, and this is the right hand side. So what I have done here, first of all, I try to convince you that this formula is indeed correct. So if you have seen the previous video there, we had the second root, and then I rescaled the fraction by the conjugate pattern of the numerator. But the conjugate pattern will not work here. Assume that I multiply this by the conjugate pattern. So the conjugate pattern would be something like this. Okay, and then the denominator would be the same expression. But now if I multiply this by that, it gives me the first one to the 2, but because this is the third root, the first one to the root doesn't help me to get rid of this third root. So it means that this will survive. I cannot get rid of that. my goal is to get rid of this third root in the numerator. So I need to multiply it by a pattern like this, okay, so that I will make this identity, and the answer would be the first one to the 3, which I will get rid of this third root, and minus the second one to the 3. So let me explain what I mean here. So I would write the limit, so I will copy and paste this first, so everything so far, yes, sorry, I will copy and paste everything so far. H goes to 0. Then I start rescaling this, but with an expression which makes this pattern for me. So if I give the role of A to this expression, and if I give the role of B to this expression, then this will read A minus B. So it means that I have to rescale my fraction by this expression, which is the A to the 2, which is what? A to the 2 becomes the first one to the 2, which is 3x plus h plus 1 to the 2. And then I have to write plus, and then I need to multiply A and B. So if you remember, I told you that I will give the role of A to this and B to this. So A times B is simply the product of these two terms, because both of them are third roots. So I can write just one third root and multiply what is below the third roots together. Yes. And then finally you see that I have the second one to the 2, so this is playing the role of B, so B to the 2 becomes plus the third root of x plus 1 to the 2. Yes? And then I have to divide by the same expression. Hopefully I can just copy this. Yes, hopefully it will work, and then I will put the same thing here. So what I have done, I have multiplied my fraction by this expression, and I divided this by the same expression. So this very big expression here is another fancy way of writing 1. Okay, by why this is useful? Because now if I multiply the numerators, it makes exactly this pattern. So the answer would be the first one to the 3 minus the second one to the 3. And it doesn't matter if the denominator is so big. Yes, so you don't need to be worried about that. So let me write it here. So the answer to the numerator would be the first one to the 3. So the first one is this. So let me write the details for the first time at least. This becomes this minus the second one to the 3. Yes, and then I will have h, and then I have this expression again here. Yeah, it was not a good place, so let me write it here. Good, and then of course I have to put a pair of brackets around that. Yes. So hopefully you understand what's going on. I have multiplied these two, and I use this identity. It gives me the first one to the 3 minus the second one to the 3, and then I multiplied this h by the whole expression, and I have written it down here. Okay, now the good point is here, this power of 3 helps me to get rid of this third root. The same for here. So if I want to go one more step, so the denominator would be the same expression. So let me write it again here, h, and copy paste this denominator here. So, sorry, the denominator would be that, but the numerator becomes the first one to the 3, which is this one, minus the second one to the 3, but of course you need to be careful to put a pair of brackets around that. Okay, And now if I go one more step, so you see, let me write it above. So if I apply this negative sign here, it becomes minus x minus 1. And then this minus 1 will cancel this positive 1. This minus x will cancel that positive x. So what is left for me is just h in the numerator. Yes. And then h times that expression in the denominator. Yes. Let me make it a little bit bigger. Okay. And then h goes to 0. And then the next step is that I can cancel this h with that h. The h in the denominator is also a factor because it has been multiplied to this big expression. And then what is left in the numerator is just simply 1. And of course this h when cancelled is 1. And then I have to send h to 0. So you see the numerator is 1, the denominator is this expression, and then I have to send h to 0. But if I send h to 0, this becomes x plus 1 to the 2. So the numerator would be just 1. The first term becomes the third root of x plus 1 to the 2. Plus, if I put h equal to 0 here, it becomes x plus 1. There is another x plus 1 here. If I multiply these two x plus 1s, it becomes x plus 1 to the 2, and I have a third root. So this becomes the third root of x plus 1 to the 2. And finally, the last term doesn't depend on h at all, so it becomes itself, which is exactly the same expression again. So that is also the third root of x plus 1 to the 2. But now in the denominator I have the same expression added to itself 3 times. So if I just continue, so let me write it here. The derivative f prime of x becomes, in the numerator I have just simply 1. In the denominator I have 3 of those factors, which is the third root of x plus 1 to the 2. And then that is exactly the answer provided by the problem itself. So this would be the derivative of this function. Okay, I hope that the video is helpful for you. This PDF file, you can download it by the link below the video in the descriptions. Until the next video, take care and goodbye.